Hey you guys, it's Mary and welcome back to Study Journey. I'm back with another AMC Problem of the Week video, and this video is mainly focused on finding the area of a circle, but there's a lot of limitations to it. So without further ado, let's get on with the video. This is AMC 12B Problem 9 from fall of 2021. Triangle ABC is equilateral with side length 6. Suppose that O is the center of the inscribed circle of this triangle. What is the area of the circle passing through A, O, and C? And here are your answer choices. So the key words here are that this is an equilateral triangle and the side length is 6. O is the center of the inscribed circle, and then it's asking you what is the area of the circle that is passing through A, O, and C. So let's draw ourselves a little diagram. So here is basically the diagram right here. And we can see that it is asking you what is the area of this circle right here. So let's name this center X. So the key points are that this is an equilateral triangle. So we know that each of these angles is equal to 60 degrees. And right now, if we're trying to find the area of this circle, then we have to know the radius. To find the radius, we can use the cosine rule that transfers degree measures to the radius. And we can use the cosine rule to find the radius if we can make the radius part of a triangle, because the cosine rule states that the square of any length of any side of a given triangle is equal to the sum of the squares of the lengths of the other side minus twice the product of the other two sides multiplied by the cosine of the angle included between them. So this might sound complicated, but we can simplify right here. So in any triangle ABC, let's let the side lengths be A, B, and C, and then the middle angle right here between B and C is alpha. So what this states is that A squared would equal B squared plus C squared minus 2BC times cosine of alpha. And this is called the law of cosine. So if we can use that in this diagram, then we can find the radius. Well, we can see that if we connect A and X and C, that these will be the radii of the circle. Since ABC is an equilateral triangle, if we connect AO, since it is the circle of this inscribed triangle, then we can see that these are also the angle bisectors of BAC and ACB. So this right here, this small angle, CAO, this will be 30 degrees because that will be half of the 60-degree angle. The same is for this one. So since these three are 30 degrees, then them added up will be 60 degrees. So since this is a triangle right here, AOC, and we know the bottom two is equal to 30 degrees and 30 degrees, so it will be 60 degrees. And the top angle right here, AOC, will be 180 minus 60 degrees, which will be 120 degrees. Now remember, we are trying to find this angle right here, which is AXC, if we want to use this triangle AXC and apply the law of cosines to it. So since this is part of this triangle X, if we put a dot outside on the other side of the circle and label it M, and then connect these two dots, A and M and C, we can see that AMCO is actually a quadrilateral inscribed in the circle X. So because of this, the angle AMC would equal 180 minus 120, and that would be 60. Because remember, the opposite angles have to add up to 180. Now, because this is 60, and M is the point on the other side of the circle, and X is the center of the circle, then we also know that this angle right here is equal to 120 degrees. We can now apply the law of cosines and find the radius of this circle. A would be AC, and since it says that this equilateral has a side length of 6, we know that A squared here would be 6 squared is equal to B squared plus C squared, so that would be the 2R's, minus 2BC, which is 2 times R squared, times cosine of 120 degrees. Now we simplify. Now remember, we are trying to find the area of the circle. So remember, the area of a circle is equal to pi r squared. Since we know that r squared is 12, then we just plug it in. So the area of the circle would equal 12 pi. Taking a look at our answer choices, we can see that the answer will be B, 12 pi.